Okay, multiplying radicals and radical expressions. So first thing, we'll multiply a couple of square roots, and these should be very familiar with you from Algebra 1. Square root of 2 times the square root of 8 is the square root of 2 times 8 is the square root of 16. Oh, that's 4. Pretty simple. Now let's do one a little bit harder. We'll go with the square root of 3 times the square root of 18. Okay. 18 times 3 is 54. It's not going to work out to be a perfect square root, so we're going to make little factor trees. So 3 is a prime factor, so I'm just going to go ahead and throw that under the square root now. And 18, oh, well, that's 18 is 2 times 9. 9 is not divisible by 2. Oh, 9 is 3 times 3. How to get the first 3? That's that one. Okay. Now I'm going to put in the rest, the 2, the 3, and the 3. So the square root of 3 times the square root of 18 is the square root of 3 times 2 times 3 times 3. Anytime, since I'm doing square roots, anytime I see a pair, like those 3's, I get to pull that outside the square root. And I don't have another pair with the first 3, and I don't have a pair with the 2, so those get to stay under the square root. 3 times 2 is 6. If I have a couple more square roots, and then we'll go to the cube roots. If I have the square root of negative 2 times the square root of 5, well, we're only going to deal with real numbers. We're not going to deal with the complex number system. So the square root of negative 2 is undefined. And so we're going to call this one a no real solution. But if I have the square root of negative 3 times the square root of negative 3, even though negative 3, the square root of negative 3 is undefined, this one I actually do have a defined value of, and that is the square root of negative 3 times negative 3. I multiply so this is the square root of 3 times 3 times, oh, I got a couple of negative 1's in there. We'll have to deal with those separately. Square root of 3 times 3, oh, well, that's 3. And this square root of negative 1 times negative 1, I don't get to call that the square root of negative 1 and just call that 1. By definition, we just bring one of the negative signs out and call that negative 3. Yes, ma'am. Oh, negative 3 is 3 times negative 1. Well, it's because the square root of negative 3 is not defined. But this is kind of a special case where we can define. If I'm multiplying the square root of 2 negative numbers together, I actually get a solution, and this solution gets to be negative. But if I'm multiplying a square root of one negative number times the square root of a positive number, then my solution is none. Um, well, it actually isn't 3i. It's negative. Yeah, it's 3i squared. So it's negative 3. Yes, sir? I did take them out. Yeah, I took them out to there. Okay. So that's a little crazy one. You won't see that one much, but I thought I'd throw that in just for the heck of it. Um, um, because I'm kind of avoiding the issue of complex numbers, although this one does kind of get into the complex numbers. Could have just left them as negative 3's and you would have been fine with it. But what would you have called the solution? Okay, then you're good. Just working through a few like we haven't seen before. Um, so let's do the cubed root now of 3 times the cube root of negative 9. Okay. So the cube root of 3 times the cube root of negative 9. I will turn this into prime factors. Negative 9 is, 9 is 3 times 3. And so I get the cube root of 3. I'll put that 3 in, the first 3 in. Then I'll put the negative 9. Oh, that's 3 times 3. And then I got to put the negative part of the negative 9. So I'll just put negative 1. Any triples I take out if I'm doing cube roots. I don't do doubles, I do triples. Yes. Yeah, if you can just multiply them and get a perfect cube, then you just cube it. Just take the cube root of it. Yeah. Okay. So this is 3 times the cube root of negative 1. What's the cube root of negative 1? Negative 1. So this is 3 times negative 1. So this is negative 3. Or the cube root of negative 27, which is going to be negative 3. And let's not belabor those. Let's go on to the more interesting ones where we got some variables going on. So let's simplify the square root of 50x to the third power. All right, I'm going to break this down into prime factors. 50 is 2 times 25. 25 is 5 times 5. All right, so 50 becomes 2 times 5 times 5. X to the third power, I'm just going to write that as x times x times x. All right. Any pairs, since this is a square root, any pairs I can bring out. Bring out the pair of 5s, and that means I got a 5 outside the radical. Bring out a pair of x's, and I've got an x outside the radical. There's no pair for the 2, there's no pair for that leftover x, so those 2 stay inside the radical. So this is 5x times the square root of 2.